Thank you, class, for joining us. In today's video, we'll be doing a review of quadratic functions. I hope that this video can be more engaging for you, where you'll better understand. So, quadratic functions, right? What we're saying is that there are two forms that you can write a quadratic function. And the first form is by using the general form, which says ax squared plus bx plus c is equal to 0. And the standard form, which is a bracket x minus h all square plus k is equal to 0. And that is the standard form, right? So both two forms can be used interchangeably and still satisfy what is a quadratic equation. All right, so the quadratic equation is the mathematical function. The shape, however, that the quadratic equation forms is a parabola. Some person call it parabola or parabola, right? And as we see from this picture, which is a local uh, construction, right, in which the structure of the dome is in the shape of a parabola, right? We also see in this bridge, right, it's formed, we see the curve, right, looking like the parabola. And so that is what the shape is called. So the shape is called a parabola, but the function is a quadratic function. And a quadratic function is a function with the x in the second degree. Okay. And so why is this shape studied? So the parabola is used to make light that have focused beam and they are moved in vehicles. So the idea of the convex lens, where you have the light shining from one point and then it is refracted from the edges or the curves of the shape, then that will give you a more um, brighter view of the light, right? And so it is then in the curve, light the light is reflected from a point, and then it shines within that curve, and it can be seen for a distance. Okay, when we usually see this in light bulb or in some cameras, or and even in some lens, right, where the light or the picture refracts from a point, and then it is able to see in on a wider aspect. All right, so what do we need to know? So we need to know how to factorize. We need to know how to solve, how to draw the graph, how to locate the roots of the quadratic equation, how to locate the axis of symmetry, how to state if the graph will be a maximum or a minimum, and to locate the and state the turning point. And also, so this quadratic graph, they can be used to solve simple inequalities, right? Method of factorizing. We know we have our ax squared plus bx plus c, right? Equals 0. Right? When we factorize that, now we are finding the pair, right? In which we will have our x, whether it is being added to something, or x, where it's being subtracted to something, will give us 0. And from this, we will have two values for x. And from solving a quadratic function, we will know that it will give us two values. In drawing our graph, we need to understand the change, right? So we know that the y values will change with respect to x, right? And so as x changes, so will the y value changes. And the roots are the 2 points on the graph where when we get these two answers for x, the function will be equal to 0. All right, so the first step in factorizing, all right. So to factorize, say we are given this function ax squared plus bx plus c, right? So we need to find the product of a times c, right? So we see our a, whatever a is and whatever c is, we're going to find the product of those two. And we should find two factors. This is the step that we need, that person need to understand. So you find two factors of A times C, that when we add it, it will give us B, and if we multiply it, it should give us back A times C. So we're going to replace B by the two factors that we found, and we're going to group them in pairs. Then we're going to put each of the factors to be equal to 0. I'm going to solve for x. So the quadratic equation will give us two answers. And as the statement says, perfect square will give us two identical values. All right, so let's try this example in which it says 2x squared minus x minus 3. As we had identified from our quadratic formula, so we write it back, a x squared plus bx plus c equals 0. The a, right, that is attached to the x squared is our 2. The b, that is close to the x. When we see the x without a number, we can safely say that a 1 should be there. So, right, so it's negative 1x, and that's why our b is a negative 1. And our c is equal to a negative 3. So we're going to factorize this, right? We're going to find two numbers. So the product of a times c is 2 times a negative 3 is equal to a negative 6. And what is our b? Our b is equal to a negative 1. So we need two numbers. When we multiply them, they will give us back the product, which is 6. And when we add those two numbers, it will give us b. All right. What we see we can do, we can use, if we have positive 2, and if we have positive 2 plus 3, plus a negative 3 rather, what that will give us? We have a 2 that will give us a negative 1. All right. If we, however, have a positive 3 minus 2, what will that give us? That will give us a positive 1. So we can't let the 3 be positive. The 3 should be a negative 3. So let's put it in this form now. So what we will have is 2x squared. Our 3 should be negative, so we have, all right, minus 3 minus 3x. Or 2 can be positive, so we say positive 2x minus 3. And what we see we did was to replace the b, which is a negative 1, by these two factors, right? Which is a negative 3 plus a 2. When we add them, we see it will give us back the negative 1. So now we are going to group them. All right, for simplicity, let's just group them by like terms. So we'll just rearrange it and say 2x squared plus 2x. Then we have a minus 3x minus 3. Okay, so we'll group this side. And what we're going to do now, we're going to factor out something that is common. And what do we see that is common from this? We see 2 is common, and we also see a x is common in both of them. What we're going to factor out is a 2x. The 2x into 2x squared will goes x times. 2x into 2x will go a 1 time, because 1 times 2x will give us back the same 2x. All right. Let's now factor out a negative 3. Right? Because it's only the 3 that is common between both of them. So negative 3 into negative 3x will goes x time. And negative 3 into 3 will go a 1 time. We can add up a plus in this bracket to let it be similar with this one. Because we know a negative times a positive will give us back the negative. Right? I wanted both brackets to be the same. So our answer will be 2x. These two terms that are outside of a bracket, we put them in a bracket, and we're going to keep one of this bracket that is similar. So we have to equate this to 0. or we say x plus 1 equals 0. So either we are saying 2x minus 3 equals 0, or x plus 1 is equal to 0. So in solving, we say 2x. We're going to add 3 to both sides. We'll have it equal to a positive 3. Dividing by 3 by 2, or x will be equal to 3 over 2, or we can say that is equal to 1.5. Okay, and now our x on this side, because we're just taking over the positive 1, we're going to subtract a 1, and our x will be equal to a negative 1. So in factorizing, the two values that we found for x is a negative 1 and the negative 1 right here, and a 1.5. So that now will be our two roots, but we shall then see how we will come up. And this is us finding the roots when we use the factorizing method. We could have used the completing the square, could also have used the quadratic formula. All right, we found these two values of x, and let's now look on if we were to draw our graph. What we are to do is to choose at least 5 values for x from the given range. I'm going to substitute each value into the equation and find the corresponding value of y. I'm going to plot the points on a graph paper and draw a smooth curve connecting the points. So from our function, which is 2x squared minus x minus 3, we have, we're going to use these values when x is negative 2, when x is negative 1, when x is 0, when x is 1, when x is 2, and when x is 3. So in applying when x is negative 2 into this function, so let's kind of rewrite it right here. So we had, if we have our 2, we're going to put a bracket to substitute our x values for. So our first value is when x is negative 2. Right? We're going to put our negative 2. So negative 2 times, well, negative 2 squared will give us a positive 4. 4 times 2 will give us an 8. A negative times a negative 2 will give us a positive 2. And this will be a negative 3. So what we have here, we have 8 plus 2, 10. 10 minus 3 will give us a, see here, all right, 2 2's give us a positive 4. Positive 4 times 2 will give us a 8. Negative times a negative will give us a positive, and a, yeah, so we have a 8 plus 2 will get 10. 10 minus 3 will give us a 7. Okay. Then now, when our x is a negative 1, we will have 2 bracket negative 1 all square minus negative 1 minus 3. Right? Negative 1 square will give us a positive 1, so we'll have a 2. Negative times negative will give us a plus 1. Then we have minus 3. We'll have 3 minus 3. That will give us a 0. Right? And as we can recall, we know that negative 1 was one of our roots. And so in the function, we can see here, when we substitute negative 1 into the function, we found that y is equal to 0. So that was one of our roots. All right, so let's test when x is and x is 0. So when x is 0, we know 0 times any number, replacing 0 in this bracket would be 2 times 0 squared, which is 0, minus 2 times 0, which is 0. So our answer will be equal to a minus 3. All right, that would be our y-intercept. When our x is 1, we 2 ones 2. So it will be 2 ones 2, and minus 1, minus 3. So we'll have a minus 4, and add that to a 2, we'll have a minus 2. When our x is 2, we will have a 2 2's. All right, so we'll have rewrite it here. 2 will be in the bracket being squared minus the 2 minus the 3. But we'll have here 2 squared will give us a 4. 4 times 2 will give us a 8. And the negative 2 minus 2 and minus 3. We'll have a 8 minus 5, and 8 minus 5 will give us a positive 3. And our third value when x is 3, our y will be 12. All right, so those was our values in which we were substituting in finding the curve. All right, so to get our smooth curve, this would be our diagram. So on our scale, we are to use the same scale on both the x and the y axis. All right. All right. We have our arrows pointing our x axis because x is expanding to this direction, the y is expanding upwards. So our first point, which was when x was equal to a negative 2, our y was equal, let's to a 7, right? Or y was equal to a 7. Then our point when x was equal to 0, this would be our one of our roots. Our when our x was equal to a negative 1, rather, our y was equal to 0. And this point now, when our x was equal to 0, we found that our y was equal to a minus 3. And this point, when our x was equal to, I think this is the 1.5, our y is equal to a negative 2. And this would form our curve, our parabola. Right? And we had also said now, when our parabola is open upwards or concave up, then it will have a y min. Because we're looking at the a. When the a is positive, then when the a is positive, the curve will face up. When the a is negative, the curve will face down. Right? It's like a smiley face. When you're positive, you face up. You're smiling. When you're negative, you face down. Oh, see math coming in real life. Wow, So some persons need to be a positive A, and having that smile, not be a negative curve and having a frown. Okay. All right. So now we had just discovered our roots by using the factorizing method. We could have also used our uh, quadratic formula, which says x is equal to minus b plus or minus the square root of b squared minus 4ac, that is all over 2a. All right, so seeing that we have already found those two roots, let's just try to test one of the roots and see if it will be equal 0. So we have y right here equal 2. One of our value was negative 1, right? So let's negative 1 square minus negative 1 minus 3. All right, so negative 1 square will give us a positive 1. Positive 1 times 2 will give us a 2. Then this negative times this negative will give us a positive, and then minus the 3. So what we have here, let's rewrite it. 2 plus 1 will give us a 3. 3 minus 3, or y will be equal to 0. All right, so we see when we substituted the negative 1, we got 0. Let's test our other root. Let's see if it's just coincidence. So our y is equal to 2 bracket 1.5 r squared minus 1.5 minus 3. Our y now is equal to 1.5 squared will give us a 2.25, and our 2.25 times 2 will give us a 4.5. So all of this will give us a 4.5. We're going to subtract this now from 1.5 minus 3. So let's do a 1.5 minus, let's add this. So 1.5 plus 3, and we will get a 4.5 as well. So y is equal, when we add these two negative, we'll have 4.5 being minus by 4.5. And so our y will be equal to 0. Okay, and so we were able to test our two roots, that when we substituted the roots into the function, we got our y to be equal to 0. Our axis of symmetry, which is an average of these two roots, right? So whether we want to, this is a method, whether we want to find the average of them, so 1 plus 1.5 divided by 2, what this will be. So we have a 1.5 minus minus 1 plus a 1.5. The 1 will cancel and we'll have the 0.5. So 0.5 over 2. 0.5 over 2 will give us 0.25. But let's test it using the axis of symmetry formula, in which we are saying x is equal to minus. Our b in this case is a minus 1. Right? And, sorry, minus 1. Right? And our a is a 2. So the minus and the minus will give us a positive. We'll have a 1 over 2 times 2, give us a 4. And we know a quarter is as a decimal. A quarter is also 0.25. Right? And so that would be our x value. All right. And as we can see here, this is our axis of symmetry. So see, we have the units. So if this is a quarter, this would be the half. So 1 would be somewhere right here. Right? And so we see the half, the symmetry is a quarter of the 1. So 1 would be here, so it's a quarter of the 1. Right? And we haven't found our y min as yet, but let's apply the formula in finding our y min. All right, so our y min is equal to this formula, and it's the same formula when we're finding the minimum point of y. Right? So let's look on this. This is our graph, right? And at this point, let's see, we see right here, we know that the graph is continually going up, right? So at this point, the graph will not go any lower than this point. It is increasing, it is going up, right? But at this point, the graph not going any lower than and whatever this number is on our graph, right? This number is, say, its number is 3. You won't see the graph being right here. The graph is going up. At this point, graph is going up on the left hand side, and it's also going up on the right hand side. So that's what we mean, right? When we say the minimum point. At this point is where the graph will go up. We don't want the maximum because the graph can go up on the positive, up onto positive infinity. Or you can be smiling from now until next year. You could be smiling from now until 20 years, So when you start smiling, which is today, you can smile until 5 days from now or 10 days from now. So yes, when you start frowning from now, boy, we don't know when you stop frowning. Yeah, that's my analogy on the frown or the smile. So let's apply now our formula in finding if our graph is y min, or at what point on the y-axis is the minimum point that y will be. Right? So our y min is equal to 4. Let's just rewrite the function that we are doing. So it's this same function, which is the 2x squared minus x minus 3. All right? So we know this is our a, the 2 is our a, the negative 1 is our b, and the negative 3 is our c. We're saying 4a is 2, and our c is our negative 3 minus our b squared. the negative 1 square. This is all over 4 times 2, which is our a. All right. So let's work it. 4 times 2 is 8. 8 times 3, 3 8, 24. And so that would be a negative 24. All right. So when we have to square first. When we square this negative 1, it becomes a positive 1. But then this negative will affect it, and it still will be a negative 1. And so our 4 times 2 will give us a 8. And so we have a negative 24 and a negative 1. We will have a negative 25 over 8. And so we will have, if we rewrite this now, we will have 3 and 1 8. Right? So 8 into 24 into 25 will go 3 times, remainder 1. I'll put that over. So it also be a negative 3 over 1 8. Okay? So our y min is equal to a negative 3 and 1 8. All right? So on our graph, where the negative 3 is, it is 3 and 1 8 at that exact point. All right. So this is where we would get it. The 2.5 is for the x, and the 3.1 would basically be our y point. Right. And so the turning point now is those two coordinates, both our x and our y coordinate, are our h and our k if we're looking on the standard equation. Okay. So this now would be our curve of the function. And this function here, let me rewrite it because it is the opposite of the function that we just did, negative 2x squared plus x plus 3. All right. What we did was to change the sign. And when you change the sign, it will become a frown. You see? First, our function was a positive, right? So we had a 2x. Sorry. Let me erase this. We have a 2x squared. Then it was minus the x minus the 3. And this gave us a smiley face curve, right? We see this, when our a was negative, it becomes a frowny face, right? So we saw that our parabola was open down when our a was negative. When our a is positive, we saw our curve pointing upwards, right? And so that would still be the same roots. All that changed the equation was the sign. So all the signs were changed. So the 2 became negative, the negative x became a positive, negative 3 became a positive, and so it changed it. Right? So now we can use the solutions of our quadratic functions to solve other inequalities or to equate some graph or more than one graph to another. So a graph that is already drawn can be used to determine the solution of another equation or an inequality that suits the line on the curve that we already know. Right? We are to draw the line y is equal to 2 on the graph, and we're going to equate this function to be equal to 0. We're going to state the values of x when the curve and the line intersects. So let's look at this. When y is equal to 2, the graph will cut the y-axis at 2, right? And so we see we already found our curve, right? And at this point where the y is 2, we see that it cuts it at this point. And then now this would be the solution where x is equal to 2 on both sides. So x is equal to 2 on the right hand side, and x is equal to a negative 1.5. But this one now, we're drawing our same graph, but then we're using a straight line where we say negative x plus 5, and we see the line with the function y is equal to negative x plus 5, and we're finding the points where the two lines intersect. Where the two lines intersect is where x is equal to 2, at this sign x is equal to a negative 2. Okay? And so what we're doing is to equating these two lines and the point where they intersect. We can also use it to solve inequalities, in which we first draw the curve, which is equal to 2x squared minus x minus 3. And on our y-axis, we're saying that it should be equal to 3. And then we're going to draw a vertical line from the point of intersection on the x-axis, and we're going to shade that region. So this is what they're saying, right? We draw where this line here, so y is equal to 3. So it's a straight line where y is equal to 3 at every point on the line, right? As we see, we intercept the y-axis and y is 3 right here. Even though the x is changing as we're going along, at this point, y is always equal to 3, right? And that's what they're saying. And so at any point, even if we're doing gradient, any point on a line, the gradient is the same. Any point on a line for a straight line, if we're saying y is equal to 3, y is equal to 3 at any point on the line. All right, and this is another solution in which we are we're doing the shading of the same function when we say the 2x squared minus x minus 3 is greater than or equal to minus x plus 5. And so these solution would be our data set. All right. So hope this was informative. If you have any other questions, please post them and we can go through them and continue the discussion. All right. Thank you for joining us. Peace.